Hello everyone, Dr. Olatujola Emi Samuel. Today we'll be having our live session. We'll be discussing the osteology of the upper limb. Sorry for the initial delay in transmission. We're trying to sort out some technical glitches. Let me call it glitches. I should have sorted it out before starting the live session. So I'll be sharing my screen. Is one of the So we have a 3D model which we'll be talking about today, but today we'll be discussing about the osteology of the upper limb. So basically we'll be talking about the clavicle, the scapula, the humerus, the ulnar and radius. Now we'll talk about the 8 carpal bones. So these 8 carpal bones, talk about all of them. Then we'll talk about the 5 metacarpals. Then we'll also talk about the phalanges. So we'll talk about the phalanges. So in general, we have about, so let's go to the upper limb model. So basically this is a full skeletal system model. So we can see this is a full skeletal system model from the skull down to the feet, to the bones of the feet. So, but today we'll be discussing the upper limb. So most of these models, we won't be needing them. We'll just go straight to our upper limb model. And here we can see, generally the sternum, so we can see this, the breastbone. So that is the sternum over here. It's not part of the upper limb, but we included it here because it is actually the point of attachment of the upper limb to the rest of the skeletal system. In fact, the upper limb is freely mobile. It can move in all directions and is only attached to the other aspect or to the axial skeleton at this tiny joint over here. We can see this connection here, this area. That's the point of attachment of the upper limb to this, by the way, is the sternoclavicular joint. From the sternum, this is the sternum, more specifically the manubrium of the sternum, that's the breastbone, to the clavicle, also called the collarbone. So this point of attachment, this tiny attachment, the sternoclavicular joint, is the only point of attachment of the upper limb to the axial skeleton. If we can remember, the skeletal system can be divided into the axial skeleton, which is made up of the skull, the vertebral column, the breastbone, and also we have the ribs. So these are the axial skeleton, while the upper limb, that's from the collarbone, the clavicle, the scapula, the upper bone, then the hip bones, the hip bones, and the rest of the lower limb makes up the appendicular skeleton. So basically, the axial skeleton forms the central framework of the body, while the appendicular skeleton forms the limbs and the limb girdles. So we call it the limb and the limb girdles. But today, since we'll be discussing only about the upper limb, so basically these are the models that we all need. So generally, we have, if we want to count all the bones in the upper limb, one from the clavicle to the scapula to the humerus, that's 3. Then we have 2 bones of the forearm, making 5. We have 8 carpal bones, so that makes 13. That's 5 plus 8, making 13. Sorry, I'm not that good in math. So then, so that's 13 with 5 metacarpals. So this 1, 2, 3, 4, 5. So that will be 13 plus 5, that's 18. Then we have the phalanges. So generally we have 3 times 4, that's 12 plus 2, we have 14 phalanges. So if we add 14 to 18, that will give us 32. So we have 32 bones in the upper limb. So just as I mentioned, we have 1 clavicle, 2 scapula, no, like the second bone is the scapula, we have the humerus making the 3rd bone. then we have the ulna and the radius. Then we have the 8 carpal bones, the 5 metacarpals, and the 14 phalanges. So we've actually discussed the upper limb before, so this is more like a summary, but this we'll be using this model, the complete anatomy model. We'll be talking about the osteology of each bone. Hopefully we'll be able to cover everything, but if we won't be able to cover everything, we'll also discuss the rest in other live sessions. So basically I'll be doing some live sessions. We'll start from the upper limb, we'll talk about the thorax, the abdominal bones, we'll talk about the lower limbs, then we'll go to the skull. So the upper limb is fairly straightforward. It is the most mobile limb in the body. It is designed for dexterity, basically. In fact, I believe one of the reasons why we as humans have evolved to be so successful is because of the dexterity of our upper limb. We've been able to manipulate objects from the simplest phones to the biggest skyscrapers. We've been able to achieve a lot because of our upper limbs. Most animals with 4 limbs, majorly all the 4 limbs are designed for support and movement. So most other animals, but in primates, the lower limbs are basically designed for support, while the upper limb has evolved majorly to be for dexterity. So we freed our upper limb from supporting and to moving us into being able to manipulate tools and to manipulate objects. So that actually gave us an evolutionary advantage over, of course, that's apart from our brain, because the major advantage we have is because of the capacity of our brain. But apart from that, I think we're able to manipulate tools, and this really gave us advantage. Because if we look at other animals, some scientists believe after humans that dolphins and some whales might actually be the most intelligent animals after humans. But we know that there is a limitation to what these animals can achieve compared to chimpanzees, for example. I believe it's majorly because of their limbs, their fins. They can manipulate objects with their fins, but these animals are very, very intelligent, but then they are limited in the way they can manipulate objects. So the summary is our upper limb has that connection, or the connection of the bones is in such a way that the clavicle is the only point of bony attachment to the axial skeleton. So this clavicular joint, which means the other part is freely mobile. Even the scapula, we can see the scapula is not directly attached to the trunk. So the major support is not coming from bony attachment, but rather from muscular attachment. There are large muscles that connect the rest of the upper limb to the trunk. For example, our pecs, that's our chest muscle, connects the humerus here to the rib cage and to the sternum. It's a large muscle in the anterior chest. So it's limb to the other part of the axial skeleton. We have other muscles, the other muscles like the rhomboids, the levator scapulae. So all those muscles basically connect the upper limb to the other part of the axial skeleton. But today we won't be talking about the muscles. That will be for another class. Basically today we will only talk about the osteology. So we'll majorly discuss the osteology of the upper limb today, and we'll start from the clavicle, of course, the collarbone. Sorry, let me see if I'm still sorry for that, just trying to check. Okay, so still working. So we'll start from the clavicle. So this is the clavicle, also called the collarbone, of course, because it forms the collar. So this is the front view or the anterior view. So looking at it from the front. This is the front view. You can see this is the lateral end of the, so I'll be using my mouse to demonstrate. This is the lateral end and this is the medial end. So if we see it from the lateral aspect, you can see it is flattened, like the cross section from the medial head is flattened. If we compare that to the medial aspect, which is rounded, so as you can see, sorry, I'll be, sorry for that delay in transmission, for that interruption. I could clinic, so I just have to quickly attend to a complaint of a patient. So this is the medial end of the clavicle. If you can see, the medial end is rounded in cross section. Compare that to the lateral aspect, which is flattened. As you can see, this is flattened. So generally we say the lateral aspect of the clavicle is flattened in cross section, but the medial end is rounded. In fact, that's one of the distinguishing features of the clavicle. So if we look from the superior aspect, now this is the lateral end and this is the medial end. We can see that the clavicle roughly follows S-shaped pattern. So we can see, if we trace the curvature of the clavicle, we can see this S-shaped pattern, this S-shaped pattern. In fact, the clavicle is convex anteriorly in the medial two-thirds. You can see, if we draw a line here, we can see that anteriorly it is convex. On the medial aspect, it is convex anteriorly, while the lateral one-third is concave. You can see it's concave anteriorly, or we can say convex posteriorly and concave. As for the superior surface, the same thing goes for the inferior surface. You can see this is the medial end, this is the lateral end. So convex anteriorly at the medial two-thirds, while concave anteriorly in the lateral two-thirds. However, you can see there is a groove. The inferior surface of the clavicle is rough. It's generally rough. You can see this ridge. So this ridge, so this depression here, so the subclavius actually passes through. You can see there's a notch, or there's a tuberosity here, which there's a ligament, so which attaches to this aspect. But if you look at it from the superior surface, you can see it's relatively smooth when compared to the inferior surface of the clavicle. Then looking at it from the posterior aspect, so this is the posterior aspect of the clavicle. So basically that is the clavicle. So as we've talked about it, so let me shift it back so we can see it articulating to the other bones of the upper lip. So medially, it articulates with the sternum and the sternoclavicular joint, while laterally, it articulates with the scapula. So we can see this knuckle-like projection of the scapula. This is known as the acromion process of the scapula. So it articulates medially and laterally to the sternum and the scapula. So generally, if we look at the parts of the scapula, it has the acromial end, which we've talked about. It has the body, which is rounded medially and flattened anterior laterally. And then we have the sternal end, which generally seems to be rounded in cross section. So those are the parts of the scapula, or of the clavicle, sorry. So if we go to the landmarks, so we can see, okay, so we've talked about the parts, the surfaces, we've talked about the anterior border or the anterior surface. So generally it's a thin margin. It separates the superior and the inferior surfaces, and it provides the origin site for pectoralis major medially. So the medial 2/3 provides the origin for the pectoralis major, this area, while the lateral 1/3 provides the attachment, the origin point for the deltoid muscle, specifically the clavicular part of the deltoid muscle. While if we go to the posterior border, so the posterior border also separates the superior and the inferior surface. It is the insertion point for the descending fibers of the trapezius muscle. So the trapezius muscle, so we can see the posterior aspect, we have the trapezius muscle. On the anterior aspect, we have the pectoralis major and the deltoid muscle. So when we are talking about when we'll be talking about the muscles of the upper limb, we'll illustrate the origin and the insertion points of these muscles. So we can see the inferior surface is generally roughened. So if it is one of the two surfaces of the clavicle, we have the superior and the inferior surfaces. So there is a tubercle, this area here. There is the conoid tubercle. There's impression here for the costoclavicular ligaments. There's a groove for the subclavian vessels, and it has a nutrient foramina. So basically, those are the features of the inferior surface. While for the superior surface, it's relatively smooth, and it is the it serves, especially on the medial aspect. The medial 1/3 provides attachment point for the sternal end of the of the clavicular head. Sorry, I'm mixing up clavicle with sternum. So for the clavicular head of the sternocleidomastoid muscle. So if we go back to the bone, so the sternocleidomastoid muscle has a sternal end which originates from this area of the sternum. The sternal end originates from this part of the sternum. The clavicular end originates from this part of the clavicle and moves superiorly to the mastoid process of the temporal bone. So those are the surfaces. Then we have some important landmarks. There's the facet for the acromion process of the scapula, which forms the acromioclavicular joint. The acromioclavicular joint. There's the conoid tubercle, just on the inferior surface of the lateral 1/3 of the clavicle. It serves as the attachment point for the conoid ligament. There's a groove. This groove here, there's a groove for the subclavius muscle. So this groove is the groove for the subclavius muscle. Generally, seems to be larger in males than in females. There's an impression here for the costoclavicular ligament, which inserts to the costal cartilage of the first ribs. So then there's the sternal, there's the articulating surface for the sternum. So this portion is covered by hyaline cartilage and forms part of the sternoclavicular joint. Then there's a line here. This is the trapezoid line, which actually serves as attachment point for the trapezoid ligament. So we've talked about the anatomy of the clavicle. So we can see, I'm trying to load the cross section. So we're having challenges with network, so just trying to see the cross section in the body, but while going through the models, having issues with the cross section for now, so we'll stick to the gross anatomy. So basically that's the anatomy of the scapula, of the clavicle. Oh, sorry. So the next bone we'll talk about will be, of course, the one I've been talking about this morning, mixing up with the clavicle. We have the scapula. Sorry, let me. So we'll talk about the scapula. So the scapula, generally, the clavicle is not part of the bones of the free upper limb. So what I'm trying to say is the scapula is considered to be the scapula and the clavicle. They are considered to be part of the upper limb girdles. That is, per se, they are not part of the free upper limb, but rather they connect the free upper limb to the axial skeleton. So the free upper limb actually starts from the humerus. So from the humerus, while the scapula and the clavicle connects the humerus to the axial skeleton. So the scapula is the second part of the limb girdle. So the scapula is the second bone that makes up the limb girdles. So the upper limb girdle. So the scapula is roughly triangular in cross section. So I'm going to isolate the scapula and we can see. So we can see it traces a triangular shape. So we can see a triangle has three sides. So we have the first side, the other side, and of course the third side. So generally a triangle has three sides and three angles. The same thing goes for the scapula. So we have the upper side, which is the superior border of the scapula. So this upper part is known as the superior border of the scapula. Then at the medial end, we have the medial border of the scapula, and inferiorly, this slanted portion is known as the lateral border of the scapula. So generally, we have the superior border, the medial border, and the lateral border, and in between two borders, in between two lines, we have angles. So in between two non-parallel lines, we have angles. So between the superior border and the medial border, we have the superior angle. So this bony projection here is the superior angle of the scapula, while between the medial border and the lateral border, we have the inferior angle of the scapula, while this rough area here between the superior and the lateral border is known as the lateral angle of the scapula. So the scapula is triangular in shape. That's three borders: the superior, middle, and the superior, median, and the lateral border. And it has three angles: the superior angle, the inferior angle, and the lateral angle. The lateral angle is modified to form this cavity, this rounded cavity called the glenoid cavity. So this portion here is called the glenoid cavity. So I'm going to view it from the lateral aspect so we can see. So this is the lateral view. So generally the scapula faces forward. It projects forward and laterally. So if we look at it head on like this, we're actually looking more posteromedially from this angle. This particular view is not straight lateral. This is more median view. So if we look strictly lateral, we can see the scapula projecting laterally, anteriorly, and a little bit superiorly. That's why we can see the glenoid cavity. So from the scapula, the glenoid cavity actually projects laterally, anteriorly, and superiorly. So it projects. Okay, again, sorry for the break in transmission. I had to quickly attend to some issues. So, just as we were saying, so the scapula projects anteriorly, laterally, and superiorly. So this is the lateral view of the scapula. So this rounded lateral angle has been modified into the glenoid cavity. So it is this glenoid cavity that actually articulates with the head of the humerus. So if we see, so the glenoid cavity, so we can see it is the glenoid cavity that articulates with the head of the humerus, So that's the lateral view. So posteriorly, we can also see the trim, the superior border, median border, the lateral border. Then we can see there's a ridge on the, also the scapula has two surfaces, the anterior surface, which is concave, you can see flat concave, and the posterior surface, which is divided into two by this ridge, this bony projection, this ridge. So this portion here, this is the ridge of the scapula. So it is divided into the, so this spine of this ridge is called the spine of the scapula. So it is divided into the superior and the inferior portion. So the superior portion is known as the supraspinous fossa. So because it's above the spine of the scapula, hence it is called the supraspinous fossa over here. While the posterior portion is known as the infraspinous fossa. So this is the spine of the scapula, dividing the posterior surface into the supraspinous and infraspinous fossae. So the spine of the scapula continues laterally into this bony prominence called the acromion of the scapula. The acromion of the scapula. So you can see the acromion of the scapula. So it is the acromion of the scapula that articulates, if we can remember, with the clavicle. So the acromion articulates with the clavicle. So then from just superior to the glenoid cavity, we can see this projection that looks like a knuckle. So this knuckle-like projection over here, also called the coracoid process of the scapula. So generally, whenever there's a process, tuberosity, tubercle, spine, whenever there's a bony prominence, ridges, tuberosity, tubercle, spine, processes, and stuff like that, it means there are ligaments or muscles or other bones that attach to that area. So those processes serve to increase the surface area of that particular part of the bone. So the coracoid process serves as attachment point for some important muscles like the short head of biceps, the coraco, so like the coracoclavicular ligament. So that's the coracoid process. So generally, the coracobrachialis also attaches to this point. So the short head of biceps, the coracobrachialis. So that's the posterior surface of the scapula. So if we go to the medial surface, so this is the medial surface. You can see the medial border is thin. It also provides attachment point for some important muscles like the rhomboids, the serratus posterior, the rhomboids, the levator scapulae, which of course elevates the scapula. Then this is the inferior surface, the inferior aspect of the scapula, and this is the superior view of the scapula. If we look at the superior border, we can see, if we trace it medially, just before we get to the coracoid process, there's a depression or there's a notch, so which we'll still talk about. So if we go back to the so if we see the description, so generally the scapula attaches both to the head of the humerus at the glenoid cavity and also to the clavicle at the acromion or the acromial process. So it has the head, neck, body, the coracoid process, the acromion, and the glenoid fossa. So this is the glenoid fossa, this is the neck. So the head is modified into the glenoid or the lateral angle. So just like we've mentioned, the scapula together with clavicle makes up the pectoral girdle. It is triangular, found on the posterior aspect of the rib cage. It has a costal surface, which is the ventral or the anterior surface, and then it has a posterior surface, which is also the dorsal surface. That's the medial, the superior, and the lateral borders. Then it also has three angles: the lateral, superior, and the inferior angles. So all right, so we'll go to the parts, the processes, and the surfaces. So this is the acromion of the scapula. So this projection here is the acromial process, or the acromion of the scapula. So it has the medial and the medial border and the lateral border. So on the medial border, that's the attachment point for the middle fibers of the trapezius muscle, while the lateral portion gives attachment point or the origin for the middle fibers or the acromial parts of the deltoid muscle. If we remember, the clavicle provides attachment point for both the trapezius and also for the deltoid muscle. So it continues laterally to the acromion of the scapula. In fact, it continues posteriorly to the spine. So the spine, along the inferior ridge, we have the attachment point for the third part of the deltoid, and also for the third part of the trapezius muscle. So basically that's the acromion. Then the body of the scapula, so we can see it has the costal surface, it has the dorsal surface, it has the medial, the superior, and the lateral angle. Then we have the coracoid process, which is the knuckle-like projection. So it serves as attachment point or the origin point for the short head of biceps and the coracobrachialis muscle. Just like I said, if we have processes, it means muscles attached to it. Also, it is the insertion site for the pectoralis minor muscle. Also, a lot of ligaments like the coracoacromial, the coracohumeral, the coracoclavicular ligament all attaches to the coracoid process. So the coracoid process, 3 muscles, 3 ligaments. The coracobrachialis muscle, the short head of biceps, and the pectoralis minor muscle. Those are the 3 muscles. Then the 3 ligaments, the coracoacromial ligaments from the coracoid process to the acromion of the scapula, the coracohumeral ligament from the coracoid to the head or the tubercles of the humerus. Then we have the coracoclavicular ligament. Basically, the ligaments attaches to the 3 muscles, to the 3 bones that are nearest: the clavicle, the scapula itself, and also to the humerus. Then we have the head, which, of course, on the lateral aspect is modified to form the glenoid fossa or the glenoid cavity. We have the neck, which is just below the head, and of course superiorly has the coracoid process. Now the head of the scapula, superiorly, just above the glenoid cavity, there's a tubercle, the supraglenoid tubercle or the supraglenoid tuberosity. So this point is the point of origin of the long head of biceps, while inferiorly we also have another tuberosity or tubercle. So if the supraglenoid tubercle is above, that means the infraglenoid tubercle will be below. So the infraglenoid tubercle is the point of origin of the long head of triceps muscle. So that's for the head of the scapula. Then we have the neck, of course, the body that we've talked about. So basically those are the parts of the scapula. Then we've talked about the surfaces, the costal surface. So sorry, still loading. So we talked about the costal surface, we talked about the dorsal surface, which is the posterior surface. We talked about the superior the superior angle of the scapula. Then we talked about the scapular notch. So this is the scapular notch. So there's a ligament, the transverse scapular ligament, the transverse scapular ligament, or the superior transverse scapular ligament, which crosses just above this notch and converts the notch into a foramina, the suprascapular foramina. So the suprascapular nerve and vessels passes through. The good news about anatomy is the names most of the times often corresponds to the structure. So this is the scapular notch, a ligament, the superior transverse, because it travels transversely. The superior transverse scapular ligament bridges this portion. So once it bridges it, it converts it into an opening, into a hole or a foramina. A hole or an opening is called a foramina or a foramen. So it converts it into the suprascapular foramen. So the suprascapular foramen serves as passageway for the suprascapular nerve and the suprascapular arteries and veins. So this is the superior angle of the scapula, which is the attachment point for the levator scapulae muscle that we've talked about, which of course rotates the scapula upward. So basically, those are the important landmarks or the surfaces. So if we go to we've talked about the landmarks. So we have the acromial angle, the clavicular facet. So we've talked about the clavicle and the scapula tonight. So our next live session will continue from the humerus. So I don't know if there is any clarification discussions, if we can talk about it. So but for now, that will be the end of this live session, and we'll continue